Good morning, good afternoon, good evening, depending on the time you come across this video. And welcome especially to the Engineer Construction Lecture Hub. Today I want to talk about a very important topic, and it has to do with the considerations. Okay, considerations in the design, in the design of ROC beams. Okay, consideration in design of ROC beams. That is the topic for today. Now, please, before I proceed, I would like you to like, share, comment, and if this is the first time you're coming across my video, do well to follow me for more useful updates. Okay, so let us go. When we talk about considerations, we are looking at those factors that we need to look critically at in the design of our beams, okay? Because you know beams are flexural members in our building, okay? We need to ensure that these considerations are, looked at critically in the course of our design. It is quite different from the design criteria, okay? Now, first and foremost, you must understand the loading condition, okay, the loading condition of the beam, okay, of the beam. Now this loading condition has to do with the anticipated amount of load that beam is expected to carry and transfer. It is very important you put that in view, okay, because in design we design from the top, so from the slab the load is being transferred to the beam. Okay, now this beam is expected to carry this load and now transfer it to the columns. All right, so it's important we understand this loading condition. All right, it's very, very important. Now another factor we are going to look at is the magnitude. Okay, the magnitude of load. Okay, now you also have to consider the weight. Okay, in terms of the self weight of the beam, you also consider the weight of the slab. You have to also consider the other weights, the dead loads that is constituted in that building that the beam is expected to carry and transfer. You must understand the magnitude of the load, so it can give you a clear picture on what you are expected to come up with the output of your design. Okay, so it is important you consider the magnitude of the load. The other thing we have to look at is the span, the clear span. Okay, the clear span. Now the clear span has to do with the distance between one support. Okay, one support, this is support A, support B. Now this clear span means the distance between point A and point B. So this is our beam, for instance. So you must consider the span of that beam in your design. Okay, when you're designing your slab, your beam rather, you must consider the span of that beam in question, because it's very, very important. Okay, because if you don't consider that, you will have problem. Okay, the deflection will be high. All right, so you must consider the clear span, okay, of that beam when you're designing a beam. The other thing we also have to look at is, okay, the cross-sectional area, the cross-sectional area of beam. All right, now this cross-sectional area of beam, for example, you have your beam in this format. Okay, you have the reinforcement running. Okay, you have the reinforcement running this way. Now when you cut a section, let's say section XX, you are expected to see something like this. Okay, if it is a four reinforcement, okay, you're expected to have something like this. Okay, so this is the cross-sectional area of this beam. All right, so you must understand that the width plays that is the breadth then the depth, that is the D, is very, very important, because when you have a larger cleared span, it means that the depth of your beam ought to increase. Okay, it ought to increase so that it can be able to sustain that load. That is why in some cases you see that you have a large span of beam, and ordinarily a layman will expect a column, you know, in between that span. Okay, but there are situations where you can drop the depth of that beam. Now that the increase in the depth of that beam can actually serve the purpose of having a column at the middle. Okay, so what it means that when you have a larger span of beam, if you give it a good sufficient depth, it can actually sustain that anticipated load, okay, irrespective of the span. All right, so you have to take note of that. So these are some of the considerations you have to make as regards to your beam design. So I'm going to stop here for today. Please do well to like this video, share, comment, and if this is the first time you're coming across my video, do well to follow me for more valuable updates as regards to construction. Thank you very much, and do have a blessed day. Thank you.